Welcome to the next chapter of this course, Defining Module Boundaries. In this lesson, I'm going to introduce you to some techniques that you can use to define your module boundaries, but I want to preface this by saying that these techniques aren't only useful when you are building a modular monolith. In fact, you can apply these techniques in any kind of software architecture or application that you are building. So with that out of the way, let's see what we are going to talk about in this lesson. Here's an overview of the techniques that I'm going to introduce you to that we can use to define our module boundaries. And they are domain-driven design, bounded contexts, which is a concept from domain-driven design, but we're going to discuss it in more depth, and a very interesting technique for exploring your problem domain called event storming. But before we dive into these techniques, let's do a quick reminder of some of the things that we mentioned in the previous lessons, and I want to start by reiterating what we consider to be a module. A module represents a cohesive set of functionalities or use cases. We combine multiple modules inside of a modular monolith to provide the business functionality that we are developing. Each module can be treated as a separate application, and all of our modules should be self-contained, meaning that they should own their data and they should have all of the information required to provide the desired functionality. The modules inside of our modular monolith also have to follow a few constraints so that we can enforce the logical isolation between the modules and to keep the modularity of our application intact. Modules can only communicate through a public API, and they can do this synchronously or asynchronously, and the data for each module should be isolated in the database, and I recommended that we should start with at least logical isolation using schemas inside of our database. So the next logical question that we should ask ourselves is, how do we find the module boundaries? Let's say we are working in some specific problem domain. How do we approach this domain and figure out what are the correct module boundaries so that we can translate this into the code and start providing business value? One of the techniques that we can use to figure out our module boundaries is domain-driven design. Domain-driven design comes from the book with the same name, and it was written by Eric Evans in 2003, which is more than 20 years ago. The domain-driven design book provides many valuable insights for how you can approach and develop complex software. Unfortunately, there isn't enough time to cover all of the valuable strategies and patterns that are introduced in this book. However, there are two patterns from this book that we could apply to our problem domain, and they will help us find the module boundaries. And the first pattern is a bounded context, which is a strategic design pattern, and the second pattern is the aggregate, which is a tactical design pattern. What is a bounded context? Well, let me first give you the book definition that says that a bounded context is the boundary within a domain where a particular domain model applies. Now, this might seem a little bit confusing. What do we consider a boundary? What do we consider a domain model? So let me try to explain this on a practical example. In this image, we can see two bounded contexts, the users and the attendance bounded context. And you can notice that in the users bounded context, we have a conceptual collection of entities called users. However, in the attendance bounded context, we have a conceptual collection called attendees. What is interesting here is that the users and the attendees could be the same physical entity in our domain. What I mean by this is that the user entity inside of one bounded context, where we also have roles and permissions for authorization purposes, could be the same entity in the attendance context, except it is given a name that is specific to that context. And in this case, it is an attendee. However, when it comes to the real world, this would be the same entity. And another way how this would be evident is that the identifier of the user in the user's bounded context would also be the same value given to the attendee's entity in the attendance bounded context. We also have the concept of an aggregate, which is a term that gets thrown around a lot, but is actually really simple. An aggregate is a collection of related objects that are treated as a single whole for the purpose of data persistence. In other words, we use the concept of an aggregate to create a logical boundary around a set of entities or objects in our domain to enforce the consistency inside of the aggregate's boundary. Typically, the aggregate is going to consist of one object called the aggregate root, and this is how the outside world is allowed to interact with our aggregate. The aggregate root could also have a reference to any number of entities inside of the aggregate and also any number of value objects. From my experience working with domain-driven design, the aggregate pattern is more valuable from the logical or domain modeling perspective rather than the coding perspective, and this is how I like to apply it. So you will rarely find the concept of an aggregate coded into my domain through an interface or a base class. However, I still apply this pattern on the logical level, and this is where I think it is the most valuable. If you aren't familiar with domain-driven design, there is something called a domain-driven design starter modeling process, and it's a set of tools and exercises that you can apply to help you discover your problem domain in a visual and collaborative way. Once you have figured out what your domain consists of, you can decompose it into smaller, loosely coupled subdomains, and then you can translate your subdomains into a loosely coupled architecture that fulfills your business use cases. If you think about it, these subdomains have a very clear mapping to the modules inside of our modular monolith. So you can almost think of a subdomain as a module that provides the required functionality valuable for the business, and when we combine multiple modules or multiple subdomains, we can architect an application that provides all of the required functionality. Here's a visual representation of what the domain-driven design starter modeling process looks like. Now, we won't be covering all of the steps inside of this process, but we are going to focus on a few of them. We are going to focus on the discover step, where we are going to try to find the use cases or events in our domain. We will try to decompose these events into possible subdomains, figure out how to connect them, and then find a way to translate what we have discovered into the code. And the first step in this process is discovery. For this step, we can use a technique called event storming, which is a collaborative and fun way to map your problem domain and explore your potential domain boundaries. How event storming works in practice is you gather all of the important stakeholders and people from the business and bring them together inside of one room. You give them a bunch of sticky notes and instruct them to write up the important domain events for their particular aspect of the business and just plaster them on a wall or whiteboard. From this exercise, you can figure out what are the important behaviors inside of your business, and you can start modeling them inside of your domain. Here's an example of the results of an event storming session. The orange sticky notes that you can see here represent domain events. There are sticky notes in some other colors that could represent users, commands, queries, policies, and so on, because event storming is a much broader concept, and I implore you to explore it in your own time, but for our purposes, it is enough to focus on domain events to start to figure out what we are modeling inside of our domain. In the rest of the course, we will be building an event management system, and here's what an event storming session for such a system could look like. All of these sticky notes represent domain events, and you can see domain events like ticket type sold out, order refunded, attendee checked in, user registered, ticket reserved, ticket type price updated, attendee marked as no-show, order initiated, and so on. This might look like a tangled mess of domain events at first, but there is a very simple way how we can add more structure to this. And the next step, after we have identified the possible domain events inside of our domain, is to enforce the timeline of how these domain events occur. So we would first have a user registered domain event. Once the user has registered, we could have a cart modified domain event or a cart cleared, and then again a cart modified. We could have a discount code applied event. Finally, after the user applied a discount code, they could initiate the order, which would trigger the order initiated domain event, which is followed by an order payment completed, which is followed by a ticket reserved and a ticket issued. And once the user has their ticket, they can attend some specific event, which could trigger an attendee checked in or an attendee checked out event. So that's the general idea of event storming. You're going to first figure out what are the domain events that are part of your larger domain, and then you're going to organize them by enforcing the timeline between the domain events. Once you have enforced the timeline, you can start to explore some potential domain boundaries by grouping together similar domain events and also grouping together the order in which they happen. Here's an example of what the potential domain boundaries could look like by organizing the domain events on a timeline and grouping together related events. So we could have one boundary here related to users, another boundary related to events, ticket types, and images, another boundary related to orders, carts, checkout, payment processing, generating tickets, issuing refunds, and so on. and then one more boundary related to attending an actual event with domain events like attendee checked in, check-in failed, attendee re-entry, and so on. It's also important to highlight that defining your domain boundaries is a continual process, and it's something that should change over time as you gain more insight into your problem domain and figure out how the concepts or the business use cases inside of your domain relate to one another. It's very unlikely that you will get the domain or module boundaries correct from the first attempt, which is why this is an evolutionary process. This is another reason why I think it is better to start with a monolith system, figure out your domain boundaries, and then you can decide how you want to extract particular domains or modules into separate services to get the other qualities offered by microservices systems. After we have completed our event storming session and figured out a few potential domain boundaries, we can apply the concept of a bounded context to these subdomains. For example, you can recall that we had some events pertaining to users, which would map to a user's concept inside of the user's bounded context. But we could also have the concept of a customer from the perspective of the ticketing subdomain, and you will often notice this inside of a business where different departments will use a different naming convention for the same concept. So what is a user in one department could be a customer in another department. And then we could have the concept of an attendee in another department. And when it all clicks is when you figure out that the user object in one bounded context is also the customer object in another bounded context, and it's also the attendee object in another bounded context. And what this allows you to do is to model your bounded context and shape them based on the business requirements of that bounded context. So in the users module, we could be working with an external identity provider, so we would store an identity provider ID. In the ticketing module or bounded context, we may need some payment information on the customer, and in the attendance module, we could only care about the events that this attendee has recently attended. Here's a diagram from before that I used to explain the concept of a bounded context, and I'm hoping that it's going to be much clearer this time around. So what we want to do is to model the concepts in our domain, the aggregates, the entities, to make them fit the requirements for this domain or bounded context. So the user entity inside of one bounded context will have the specific behavior required to fulfill the requirements of that bounded context. And the attendee, which is the same object in a different bounded context, will have different behavior in that bounded context and possibly some different data associated to that entity. So now that we have completed our event storming session and we have figured out what are the bounded contexts that are part of our domain, we can start to translate these bounded contexts into modules that will come together to form our application. So let's say that these are the 4 bounded contexts that we have identified in our system, and from here we can start to translate them into the modules, or at least a conceptual model of the modules, which could look something like this. We have the users, events, ticketing, and attendance modules with the respective entities inside. We're going to be exploring these modules in depth in the upcoming lessons and chapters in this course, but for now, what are some of the other considerations that we should make from the technical perspective when it comes to defining our modules? As I said, getting the boundaries right from the very first try is highly unlikely. So here are a few questions that you should ask yourself that could help you design better module boundaries. The first question is, how often will your modules communicate? This should be a good indicator of the degree of coupling between your modules. You also want to consider how you're going to share the data between your modules. My recommendation is storing a local copy of all of the data that you require, but then again, I'm more confident of working in an event-driven system, and if you are just starting out, it might be simpler to just work with a request-response approach where you ask another module for the data that you require. Another question that you should consider is how you're going to deal with eventual consistency. If you decide to implement asynchronous communication between your modules using messaging, this is something that you will have to solve. And usually, a small delay before your system converges to a consistent state isn't problematic, but if you don't plan for failure inside of a message-driven system, you will run into trouble very quickly. And I'm going to finish off with 2 quick conclusions from my experience of building modular monoliths. And the first one is that you should spend more time than you think you should defining your module boundaries. This will pay huge dividends later, but it's also okay to do your best guess when you are just starting out and then evolve your boundaries over time. Part of this evolution of your architecture or module boundaries could be merging together chatty modules, which is why I highlighted the question of how often will your modules communicate. It should be a very big red flag if two modules are very chatty with each other. This could mean triggering behavior from one module in the other, or constantly requesting data back and forth, where you might be better off just merging these modules together and having the behavior and the data both readily available inside of a single